Thank you, Mr. Chairman. Good afternoon, dear colleagues. I think that anybody in this conference can apply some different dynamic effects of fracture. We suppose that, and we believe that there are some of these effects have fundamental base for understanding of fracture and dynamic loading. One of them is the time dependencies of strains, which have static dynamic branches, or static branch correspond enough slow loading and constant strains, and dynamic branch corresponds to enough fast loading and unstable behavior of strains. It is conventionally to plot strain rate dependencies for understanding of behavior of materials under dynamic loading. It is supposed that for every strain rate correspond only one value of strains. But in many works in last decade, you can find some strange situations when with stabilization and reduction of strains with increasing of strain rates. In our previous work, we shown that these situations can be explained very easy and with enough to know stress profiles in the area of fracture and time of fracture. All these effects well known for fracture of solids, but when we started to study the electrical breakdown, we found that for the different physical processes there are very similar effects. Firstly, I want to remind you what means electrical breakdown. Here you see the typical setup for electrical breakdown. Very simple, placed between two electrodes. One electrode connected with a generator of high voltage, and another is ground. So you can measure voltage or current for every electrodes. Electrical breakdown is formation of plasma channel in the electric gaps between electrodes, and this mechanism can have different nature, but the main principle is next. There is a free electron which can move under action of external electric field, and when this field has a critical value, kinetic energy of this electron enough to collision with another particle and splitting it to another particle with plus and minus signs of charge, etc. Step by step, providing a channel between electrodes. It is time-dependent process, and it is generally accepted to plot field time characteristics like this. Such characteristics have two static and dynamic branches. And moreover, in our experiments, we found that electrical breakdown can happen with delay. Here you see the black line which corresponds to one electrode, blue line which corresponds to current of another electrode. So this time is delayed. If summarize this effect, you can conclude that at slow loading strains characteristics constant, and you can use very simple condition for predicting of material behavior under slow loading. But on dynamic loading, strange parameters, unstable, and conventional loading rate dependence are not characteristic of materials. We should take into account history of loading, but how can we do it? We usually use incubation time criterion, which have the next form. And this criterion has two parameters, only two parameters. One of them is well-known static limit of local force field, and another incubation time, which is stated with dynamics processes preceding failure or breakdown. If you know these parameters, calculation for predicting critical stresses very simple. For this, it is enough to substitute profile of force field in the criterion. For example, voltage profile or stress profile. Let's see the result of such calculation. This slide presented the time dependence of limiting characteristics, and you can see that for calculation of static dynamic branches, it is enough to know only two parameters, incubation time and static strength. The same for electrical breakdown. Take note that in case of different thickness of between electrodes, it is enough only one incubation time, and in spite that we should have two value of electrical strength for different thickness of the electric gaps. Here you see the substitution effect of limit stresses. It means that one material has lower strength than another, but increasing our stress rate or reduction of time to fracture, the situation can change, and more weak material can be stronger. This effect is very important from engineering point of view, because when we want to design some structure, we usually compare two value of strength from table which we received at static loading. But such approach can be wrong for dynamic loading. So it is enough for comparison of two material to compare static strength at slow loading and incubation time for dynamic loading. Here you see two typical cases for failure and breakdown with delay. First cases correspond when fracture or breakdown can happen on leading edge of pulse of triangular form. So if we will reduce amplitude and duration step by step, so that stress rate or voltage rate was the same, you can receive a fracture or breakdown on the trailing edge of pulse. The next cases, we have only one duration of pulse, but we can change the stress rate or voltage rate by means growth of amplitude. So increasing amplitude lead to decreasing of time to fracture. So at very unloaded pulses, we can receive the fracture or breakdown on the leading edge of the pulse. It is very typical situation for spall experiments, when spall experiments for foil, and the femto and picosecond lasers, also for pulse electrical breakdown, because limit operation characteristic of the task. So in conclusion, we can say that these two different, physically different processes have the same effects, which can be predicted on the same approach. And this effect shows the fundamental importance of investigation incubation process preparing fracture, failure of phase transition, breakdown. And the parameter with dimensions of time can be universal basic characteristic of the mining stage and should become one of the main material parameters to be experimentally determined. That's all. Thank you.